So hello friends, today we'll be learning important numerical from the strain energy method, or we can also say it as a real work method. So we have given a question where we have this beam and we have to find shear stress due to bending and the deflection at C. So let's get started with the solution. So at first we will draw a free body diagram of this beam. So let's draw it. And so we have this A here, so we have vertical force here and the horizontal force, and we have roller support. Since roller support just have the vertical force, so we have BV, and we have here 20 kilo Newton, and C and B and A, and we have a 5 meter distance, and similarly we have 2 meter distance. So now let's find these forces through the equilibriums. So we can find the reaction force from we can just take the movement along A. So we can just take the movement along A. So we'll have a negative BB into 5, and similarly we'll have 20 into 7. So we will get VV as 28 kilonewton upward, and similarly we need to find another reaction. We found VV reaction, and we need to find VA reaction now. So we'll just use this formula of this, and we will have BA plus VV, and we can just equate to 20 kilonewton. So after solving this, we get a minus 8 kilonewton, which is downward. So we just found reactions. So now to find the shear stress, we'll just take section like A, B section and BC section, and we'll just measure shear stress at x distance from the point. So we'll just take point this A, and it will be like x distance from here, and just take point C, and it will be like x distance from here. So similarly we'll make a table. In table we'll keep portion, origin, limit, and similarly we'll take mx. It's like movement around x distance, movement around x, and we have the constant. We have E is equals to constant. So yes, we don't need to take E here. So we'll take portion AB at first. We'll take portion AB at first. So we just go for AB, and we'll take origin as A. So A at x distance. Okay, we have limit of 0 to 5, and at x distance, if we just keep the value of BA, it's minus 8 kilonewton. And if we just take the moment about x, so for the moment we need to understand this and this and this and this. So yes, if you take the moment from the left side, then anti-clockwise, clockwise will be positive, and if you take the moment from right side, then anti-clockwise will be positive, and if you take the moment from left side here in downward, anti-clockwise will be negative, and here similarly here clockwise will be positive. So we can just see here mx. We can just see here moment about x. We can see here it's kind of clockwise. Yes, if we just take from the left side, since we are taking from the left side, it's clockwise. So we can just write what do we have, minus 8 kilonewton into x. So we can just write it as minus 8x, and similarly we'll take the force on BC here, and we'll take origin as a C, and draw a line of x distance from the point C, and we'll have the limit of 0 to 2. Yes, so similarly here we can see we are taking the moment from the right side. So we have 20 kilonewton force acting downward. So if we take from the downward, we can see it will be clockwise in the right side, and clockwise in the right side is negative, so we will have negative 20x. So yes, we got equations. So now we have the formula for the shear stress due to bending. Its formula is you can see lower limit by upper limit, and it's mx whole squared by 2ei. So let's apply the formula. So we have v wb, so we just take this to 5, and we have mx, it's minus 8x whole squared by 2ei, and similarly we have 20 and minus 20x whole square by 2ei. So if we just take common 2ei, so it will be like 2ei 0 to 5 minus 8x whole square plus 0 to minus 20x whole square. So we need to solve it now. We can just put this in the calculator and we will get answer. So let's head towards calculator. So you can see the calculator in the screen. So now we'll just solve the equation. So we'll just at the integration of we'll just say the integration of minus 8x 8x whole square, and its limit starts from 0 to 5, and similarly we'll take the integration for minus 20 x whole square, and we have the integration from 0 to 2, and if we just find the answer, we'll get around we'll get 1 by 2 ei 2613. So yes, we just copy down the answer 2613.33. So yes, the value of the E is given as 200 into 10 to the power 6 kilonewton per meter square, since everything is in the meter. And similarly we need inertia. So since we have given the length and the breadth of the box, so we'll just apply the formula bhq by 12, and it will be around 0.1 into 0.12 whole cube by 12. Okay, so just let's calculate the ei. You can just calculate ei from here. So yes, if we just calculate the ei, we will get around 1.44 10 to the power minus 5 m power 4. So we'll just put the value here and just solve it. So we'll get around 2613.33 by 2 into we have e 200 into 10 to the power 6 and 1.44 into 10 to the power minus 5. So yes, so let's solve it in the calculator. Just go for solving. It's 2613.33 by 2 into 200 into 10 to the power 6 into 1.44 into 10 to the power minus 5, and if we just get the answer of around 0.4537. Yes, 0.4537 meter. So this is the stress So this is the shear stress due to bending. Okay, we got the shear stress due to bending. So this is stress due to bending. So we just got the one answer. And similarly, we need to find the deflection. Deflection. Yes, we need to find the deflection. So for deflection, we have the relation of shear stress due to bending is equals to work done. So we can just write work done is 1/2 applied load into deflection. So if we just need to find deflection, we can just b into 2 and we have p. So if we just solve it, we have stress due to bending 0.4537 into 2 by we have applied load 20 kilonewton. So we can just keep it as a 2, and if we just solve it in the calculator, okay, 0.4537 into 2, and we have 20, we'll get 0.04, we get 0.04573. so that is a deflection. We'll get 0.04573 meter. So that's the deflection. So yes, answer may be correct. I don't know, I don't make sure about the answer, but the process and the concept is totally same. So yes, that's it for today. See you in the next video.